Hello, my name is Stella Van Ness, and I have been researching calcium-2 absorption in quasar spectra with the help of my research advisor, Dr. Monnier. As a bit of background information, a quasar is an extremely bright, extremely distant celestial object. And if there's a cloud of gas in between Earth and a given quasar, we can study that gas by looking at the quasar spectra. I've been looking at 11 different quasar fields that show signs of calcium-2 absorption in their spectra. Data for these fields was obtained using the Gemini 8 telescope, which is located in Chile. My goals for this research were to reduce the spectra and analyze it in order to confirm if there is any calcium-2 absorption within those areas. If calcium-2 absorption is confirmed by any of the quasar spectra, I would then look at the spectra of the galaxies associated with that field and see if the same red shift for calcium-2 as in the quasar is present in the galaxy spectra. Finally, if a galaxy does have that same red shift, I would use two-color imaging in order to examine the properties of those galaxies. Calcium-2 is interesting to look at because of the Fraunhofer lines, which I have circled in red on the spectra in the center of my poster. And calcium-2 absorption can also be indicative of star formation. The production process of this data is very rigorous and can be pretty time-consuming. The main steps include subtracting off all of the background noise from the spectrum, calibrating a wavelength solution that matches up to the pixels of the original data, and extracting the spectra for each tilt associated with the quasar field. There are 3 different tilts, so it would have 3 different spectra that I would then sew together in order to obtain the final result. On the bottom left, like in the center of my poster, the left image is an example of a raw file. So that's a file that I just downloaded off of the Gemini Observatory archive. The middle picture is the same file that has been through a few of the reduction steps. So you can see that all of the extra white lines and all of the little white dots have been subtracted off. An important note is that each row in these 2 images corresponds to one spectra. So one row would represent the quasar spectra, and the rest of the rows represent the galaxy spectra within that quasar field. On the right, you can see a graph of the final extracted spectra for a quasar. So this is after it has been extracted and stitched together and everything. This is what the end results look like. So far, I have been unable to confirm any calcium-2 absorption. This is not surprising since calcium-2 absorption is such a rare thing. I still have a couple more quasars that are in the last steps of the extraction process, so I'm hoping to confirm calcium-2 absorption within those spectra. Thank you.